My name is Andre Dovichev, and I was in charge of programming the microprocessor. This is Gabriel, who's in charge of programming transceivers. This is Kenny, who's in charge of hardware. Pramod was in charge of power management, and Albert was in charge of designing the digital filter that we use inside the product. Okay, our goal is to design a product that would help monitor your personal assets and make sure that you don't lose them. Something that would notify you if you left something behind that you really need. This is intended to monitor something like your laptop or your cell phone, something important, not something like a pen. So this would be something that would be placed on your objects, and they would communicate with a monitor that you would have clicked on you, like this thing right here. And this thing would monitor the distance between you and each of one of your objects that you're trying to keep track of. And it would notify if that distance is too great. It does this by sampling the signal strength between each device. And then it does an algorithm through a filter out the data to make sure that it is reliable, so that there's no, to make sure that the information signal is actually the distance, not some random interference line. And this would notify the user by activating some sort of buzzer or an LED or something. So if you were to suddenly drop something, like if you were to drop your keys and not realize and walk away, it would notify you before you get too far away. So for this, it needs to be something that is portable, right? You don't want to carry this bulky thing on you, plus the thing you attach to each device that you're trying to track cannot be too large either. So it also needs to be wireless, and the wireless needs to attain a certain range of at least 15 feet. So you can monitor anything in your proximity and not necessarily on you. And also it has to have both power consumption. It will have to run on battery, obviously, that's wireless. And batteries, you don't want to have it something that consumes so much power that you're constantly replacing batteries all day long. So those are our requirements. So the way we achieve this is by placing ZP transceivers on objects. These transceivers would send a signal to the monitor, which contains a ZP transceiver that functions as the receiver, and it would then be connected to a microprocessor, the 18 MHz 320p. The microprocessor would then analyze the data intelligently, because here's the thing, a lot of the data that comes in, signal strength, there's a lot of variation. If you're moving your device, you will get a lot of noisy data. So it needs to be smoothed out so that you don't have some sort of random spike activate your buzzer. You don't want to have it be unreliable, tell you, hey, you left your thing when actually you did. So we're using a fifth order digital low-pass filter to smooth it out. And then we want to make sure that there is a consistent data that says that you're above that set threshold, that is too far away, so that a single sample cannot throw it off. So it waits till it receives 5 consecutive samples before alerting the user. That way you don't get any false alarms or anything like that. The important thing here is it has to be reliable. You don't want it to annoy you if you look at all day long, telling you that, hey, you left your stuff when you really did. So ways that this thing can be improved next semester is it needs to be made smaller. Right now, we can use a smaller processor, we can use smaller transceivers. And also, we're kind of lacking in the power management department a little bit, because they consume a lot of power now, but that can be easily fixed by implementing sleep cycles into the transceivers so that they're not constantly transmitting. So that will create a small delay. So you won't notify you immediately if you leave something behind, but if it's delayed by maybe 3 seconds, that would be okay. So like you drop something or you leave something behind, you walk away, and then in 5 seconds it beeps like, hey, you left your stuff. Oh yeah. And you go back again. So that's it.
Questions? When you decided to build this from that particular sort of development kit and those modules, what led you to creating new hardware for something else that somebody would have to carry around? Are all you guys EE or are you CS or what?
We're EE.
You're all EE. Okay, but this is fundamentally a programming project in many ways, right? So why didn't you consider creating an app for an iPhone or something like that, a device that you already have?
That is something we considered, because but that would require us using Bluetooth, and we kind of want to stay away from Bluetooth because that generally consumes a lot of power, more than the Zigbee protocol.
How much research did you do into RF technologies when you selected Zigbee?
Quite a bit.
Quite a bit. So you just said Bluetooth consumes a lot of power. There's a Bluetooth low power spec.
Right, but Zigbee is designed for even lower power applications.
Okay, so Bluetooth 4, the Bluetooth 4 low power spec will use less power than the Zigbee Max. And it exists right now, and it's got the range that you guys need. So that's why I'm asking how much research you did.
Okay.
Okay.
In terms of the fundamental method to detect that the object is too far away, is the algorithm going to be confused if the receiver is on this side of my body and my cell phone is here? Would that be interpreted because I'm blocking the signals in some
Right,
way?
there's obviously a small level of interference.
So there is some.
But it won't react to it because it will smooth it out.
Well, if I keep sitting like this, it might think that my cell phone is 20 feet away instead of just 2 feet.
Well, we set a threshold a bit farther than that, right? You
Okay.
have to get some distance between.
Okay, so you tried to see how that affects.
Right.
Okay,
But
good.
we did tests, and also it doesn't matter which way the receiver is facing, because it doesn't have a perfectly circular radio signal strength thing. So, but that didn't play a big role. You need to get a big distance before you can. Target a distance like something at least 10 feet before it actually goes off. So if it's on you, it won't notify you. Or if you send it down to the ground or something, it won't go off. That's pretty important.
Okay.
How do you deal with, so let's say you become very successful, everybody in this room has one of those things. Do they interact with each other? Do they interfere with each other? Do you have a scheme to avoid that?
The transceivers we use are actually very convenient for that because they only react to a certain network address that we set beforehand. So that's something that's programmed into the transceivers, and each one will have a unique 16-bit address that it listens to. So you won't interfere with any other devices, any other networks.
Last question. Did you look into the problems with putting batteries on your assets and keeping those batteries up? And I'm assuming your life won't be much more than a few months. Your battery life? Did you spec, did I miss it? Did you spec the battery life?
No.
Okay. Did you look at all, trying to go passive on your asset tag?
Well, these are RFID tags. So. We didn't look into RFID tags because the passive tags, you would have a lot of power on the transmitting end. And that means you have to carry some huge thing around with large power. So.
I mean, Zigbee's not bad. I mean, it's just got that battery.
Right.
I assume next time you'll have a estimate of your battery life. That's the battery life.
Right. Now we predict it to be, well, it really depends on usage, to how much of the day are you having this thing on.
It's a dumb tag. It doesn't know. I mean, it's going to transmit all the time, right?
We're thinking of adding, an on-off feature.
Okay.
Right, because you don't want it monitoring all day. Like if you're sitting in your room, you don't want to keep, you go to the bathroom, you don't want it to alert you all of a sudden. You can fit your own home, right? This is more useful whenever when you're outside your home, like in a working environment.
Okay, we're going to have to stop here. Thank you.